a session on improving competitiveness of Indian manufacturing through appropriate and affordable automation towards Atmanirbhar Bharat. This session has been organized under the aegis of Industry 4.0 Expert Committee of BCIC. We would like to specially thank Mr. N Chandramouli, past President and Chairman of the Industry 4.0 Expert Committee of BCIC, and also Mr. V. Jagannath, Co-Chair of the Industry 4.0 Expert Committee of BCIC, for curating this session for the benefit of our members. The speaker for today's session are Mr. Pradeep David, General Manager, Universal Robot South Asia, and also Mr. V. Jagannath, Co-Chair of the Industry 4.0 Expert Committee of BCIC and Business Head M2 Next BFW Subsidiary. The session will be moderated by Mr. A. N. Chandramouli. On behalf of the BCIC, we express our sincere thanks to Mr. Pradeep David for accepting our invitation to address on this important subject. We also like to thank all the participants for joining today's session. We request all of you to kindly mute your mic and webcam options. This is to enhance and keep the bandwidth strong as well as avoid unwanted disturbance in the background. So I request kindly to mute your mic and webcam options. Please post your questions in the chat box only. The speakers will respond to the questions during the session, and in case time do not permit, we shall be sharing the queries to the speakers and shall revert back to you accordingly. May I now invite Mr. A. N. Chandramouli to inaugurate and set that context for today's subject and also moderate the session. Thanking you once again to all of you. Sir, over to you, Sir Chandramouli, sir.
Thank you, Mr. Prithvi.
Thank you, sir.
Thank you, Mr. David. Thank you, Mr. Jagannath. And thanks to all the audience. Are you able to hear me, Mr. Prithvi?
Very clear, sir. Please go ahead, sir.
I hope you are able to see my opening slide.
Slide is on, sir. Yeah, we can see, sir.
BCIC webinar 15th October, affordable appropriate automation. You are able to see that?
Yes, sir.
Yeah.
Great. So once again, thank you all and welcome this morning to the very, very contemporary subject called affordable and appropriate automation. The reason I chose this topic as a very important contemporary subject is explained in the following slide. Given the huge unemployment and shortage of skills in India, what are the appropriate automation and digital manufacturing principles? I'm saying automation and digital, they go hand in hand now. I think the era of automation, which is born around 20-30 years back, and the era of digitalization and internet-enabled systems started a decade ago, have come to a confluence of what I call as a automation with digitalization or digitalization with automation. And what should be the manufacturing principles of automation, digital manufacturing one should consider for his industry, for one's company, for one's division, and finally, of course, the factory or even the department within the factory. This is my first theme, which I would like to get answers during the topics, during the presentation by Mr. David and Mr. Jagannath. The second one, given the cost of automation, the first one is about appropriateness. That means suitability. Suitability of the automation is my first question. Second one is the cost. The cost of automation and the cost of digitalization and the value it generates for the business and the customers. Is such automation and digitalization affordable to medium and small enterprises? Not to speak of the large companies as well. So the appropriateness and the affordability are the two concerns which bothers all of us when it comes to automation and digitalization. Is it just a buzzword called Industry 4.0? And Bangalore Chamber of Industry and Commerce have got 800 members, of which 400 are in manufacturing sector. And all of them are, through the corona and other reasons, facing an enormous amount of challenges. I hope today's panel discussions and presentations will hope to achieve and address some of these challenges. We have two great speakers today. Mr. Pradeep David, General Manager, South Asia of Universal Robo, which is a Danish multinational. Mr. Jagannath, Business Head, M2 Next, which is a subsidiary of the great Bharat Fritz Werner. I request all the audience to mute their mics other than the speakers and panelists. M2 Next is a new division of BFW. It's a separate business entity, strategic business unit, focusing on automation with digitalization. A short, brief profile. Mr. David is a general manager for South Asia at Universal Robots, as I mentioned. He is a highly qualified expert in robotics and industrial automation, with a master's in robotics from Clemson University and MBA Market University, America. It's a rare combination of having robotics and industrial automation and management science. And you can see in his presentation how these two are converging and contributing to the society. With over 30 years of experience, Pradeep has worked with Rockwell Automation in America, Singapore, and India. In a short span of time, he has become a name to reckon with for setting up and heading the operations for the South Asian region for Denmark-based Universal Robots, the leading manufacturer of advanced, user-friendly, and lightweight collaborative robotic arms. I think Rupa should mute the others who joined later. I'm getting a lot of noise.
I'm doing it, sir.
You have to be very alert on new entries and keep muting them. There's a huge factory noise I'm hearing. Mr. Jagannath, business head of M2 Next BFW, graduated 1990 from Bangalore University in Bachelor of Engineering Electrical. Senior management professional, 30 years of experience in catering to machine tool builders, auto OEMs, two-wheeler, four-wheeler, heavy commercial vehicles. Getting a huge noise, Rupa. Auto ancillary manufacturers, metal cutting, robo integrators, vertical machining centers, turnkey, fixture and tooling, plastic manufacturers including mobile phones, medical industry, tool rooms, and wire cut EDMs. Robotic automation project including machine tool, welding, furnace, ladling, die cast extraction, two-wheeler style painting, tire handling, electronic PCB automation, and so on. Automated guided vehicles, design and development, 3D printing, polyjet 3D printing, metal 3D printing. You name it, across the board, many of the Industry 4.0 technologies, Mr. Jagannath has specialized over the last 30 years, integrated over 3,000 CNC machines in the last 2 years with successful installations up to the enterprise level. Co-chairman of Industry 4.0 committee, he supports me in this mission. Next 2 to 3 years, we'll be launching many such webinars. My vision is to have at least one such interaction per week. And with the great support of Bangalore Chamber of Industry and Commerce, Prithvi and Rupa, and our president, Mr. T.R. Parasuraman, Senior Vice President K.R. Shekhar from Deloitte, T.R. Parasuraman from Toyota, and K.R. Shekhar from Deloitte, and Dr. Ravindran, who himself is an entrepreneur and a specialist in startup ventures, are giving a great push to this particular subject in the next 2 to 3 years. With that, I would like to hand over and request Mr. Pradeep David to make his presentation, and followed by Mr. Jagannath. Then I will raise some panel discussions at my own level. And in the meanwhile, I request all the participants to start putting their questions right away in the chat box. And around, yes, thank you. And around 40-45 minutes from now, we will have the panel discussion, and followed by that we will have public or the audience question answer. Thank you so much.
Thank you, Mr. Chandramouli. Yes, and hopefully my screen is visible. Just a quick check that the screen is visible.
Yes, it is visible, sir.
So thank you everyone for taking the time to join us today, and to BCIC for organizing this session. What we're going to talk about is affordable automation, appropriate and affordable automation for Indian industry. And I'm going to focus on one particular tool that's available, and that's called the collaborative robot, cobot. So what you see on the screen right now, hopefully you can see the video. It looks like a human arm actually, right? So this little device You probably have seen robots all over the place, but this is slightly different. We'll explain what a cobot is. Cobot means collaborative robot. Notice there's no fencing. The operator is walking close by to it. It's kind of a friendly tool that helps you do your job better. Okay. So once again, imagine it's a human arm, a third arm, if you would, of your operator. What can this thing help you do is what we're going to talk about as part of appropriate and affordable automation for India. So greetings once again from Universal Robots. We are the pioneers and leaders in the field of robotics. Since we're in the COVID era, I always like to start with this first slide. See how collaborative robots are helping in the COVID era. So the top left video, it actually shows a little arm, like a human arm once again, holding a dispensing gun. And this is in Singapore. It's dispensing some kind of fluid to sanitize that area. Okay. The top right, the same arm has been put on an AGV, and it's moving around and it's disinfecting using an ultraviolet wand, if you would. Bottom left, you can see that the cobot arm is actually taking samples of the throat, instead of having a doctor do that, because it's got a force-talk sensor, it's able to feel the back of the throat without putting a human being in danger. It's actually doing the test. And what's most exciting to me is the bottom right. This is actually a car factory in Spain. Spain had a lot of outbreak of coronavirus in 3 months ago. But here is a car factory which is actually making respirators, because respirators was the need of the hour 3 months ago in Spain. The beauty here is this collaborative robot was used in a riveting application or a drilling application in the car plant. They have just picked it up just like a tool, brought it here to make respirators in this case. Okay, so this shows you the flexibility that this particular tool, it's not like a robot which is made for one purpose and one purpose alone. Different purposes based on my need. Okay, and I'm starting my stopwatch also so that I have my 25 minutes planned. Okay, so Universal Robots, we have just one quick slide about the company. It's about less than 1,000 people. It's a small company, Danish-based. But the important number is there. The number of cobots we've installed is close to 50,000. There's no other company in the world that's installed so many cobots, and we actually boast of 50% of the market share in the globe. Okay. What's also very important here is we go to the market with 700 partners, which basically means if you need something done in Bangalore, right, we will find a good system integration house or a partner in Bangalore to service your needs. Okay, so long term, they can address your Industry 4.0, deploying a cobot, etc., right here in Bangalore or Hoskote or Mysore or wherever you might be. Okay. So what is the difference? The first question I get is between a robot and a cobot. Well, look at the picture on the left and look at the picture on the right. Can you straight away tell the difference? What is I know it's not an interactive session, but so I think you can see this big yellow fence that's there on the left, right? So the fencing itself is no problem, except that for SMEs in India, space is a huge concern. Space is very expensive, especially in Bangalore. And in order to use up so much space on the shop floor just because I put a robot is not very smart. Okay. On the right-hand side, you see a collaborative robot. It's friendly with an operator. It's not going to kill him. Unlike robots have been known to kill people, right? In the past, that those accidents have happened. You can actually work side by side with a cobot. Okay. So typically a robot is for large fixed, it requires a safety cage, repetitive applications, same part I'm making 24/7, that doesn't happen very often today. In today's manufacturing, I need something small and flexible because that operator didn't show up on machine 2. I'm using it at machine 2 to load and unload the machine. Tomorrow, the operator in machine 17 calls in sick with COVID. Well, I can move this tool to machine 17 and it's now helping me be productive. Okay. I have customers who actually do this within the same shift, move the cobot around. So flexibility is a huge benefit. You notice in this case, he's got it on a little cart and he's moving it around on casters around the shop floor. So The concept of partial automation is introduced here, which I'll talk about a little further on. And for SMEs particularly, the return on investment becomes very compelling because I'm not just using it for one application. I'm using it for multiple applications, maybe one in the night shift and one in the day shift, one type of application. Okay. Now, this is unprecedented in the world of robotics, which is where the power of a cobot comes in. So from a business driver perspective, if you're looking to improve your quality, the speed of your operation, your productivity or whatever it is, your efficiency, OEE, and you want to reduce your costs. Well, how do cobots come into this kind of a scenario? Well, they help you reduce floor space. We already showed you that we don't need a cage. It reduces complexity very easily because I can do partial automation. A human being can be present along with the cobot. I don't need to make massive changes in my layout. Okay, so these two things reduce, and what it helps me increase is my flexibility. I can use it on multiple machinery. Okay, it increases my efficiency dramatically. It helps my quality go through the roof. We have customers who have told us that since they've installed cobots, they've had zero defects, zero. Okay, and this is for the last 3 years. So improved ergonomics, so if you've got back-breaking work for your operators, this makes it much more easy and friendly to use. Okay, so these are some of the benefits that you have. So the question that I often get is, okay, this is fine for Bajaj Auto or Tata or Mahindra. These guys are big, they can afford it. How about me? I'm just an SME, and can I afford to put, well, look what your brothers are doing around the country. Okay. Top left, that's an SME in Pune. This guy makes automotive parts. He's put a cobot in to load and unload his CNC machines. Top middle, they can see a woman there. She's operating in Jamshedpur. This is a small SME called New Engineering Works. And he has put in cobots between two machines. And he's trained the existing operator, okay, to operate the cobot. Okay, so it's safely operating alongside the worker, improving efficiency and all the things I showed you on the last slide. Top right here in our very own Bangalore. This was a video we shot during COVID, wherein this particular small little company called Krishi Irrigation that makes little valves, irrigation valves. So they used to have a problem finding labor to put these valves into a leak testing machine. So you see the operator there. He is now programming the cobot to pick up the valve, putting it in a leak testing machine. Okay. So I have a nice little video on this, which was done in CNBC. It's a Hindi video. If I have time later on, I'll show that. Bottom left, a small manufacturer in Pune, Shruti Engineers. This guy has 10 CNC machines. His existing operators now program the robot, the cobot, to load and unload the machine while they're doing much more value-added stuff to improve the quality output of the plant. Bottom middle, Sai Engravers. This person does little painting jobs for automotive components. He found that
it's not visible, sir.
It's not visible?
No. It's your video.
No, it's not a video. It's not a video. It's just a. I just put. Yeah. It's not a, okay.
I think you have selected the wrong screen to share.
Is that right? Okay. Well, I think it's got unshared, so I need to share it again. Sorry about that. Now, can you see it? Yes.
Yes.
Okay. Thank you for that. Once again, these are all the SMEs. Hopefully you can now see that. That's the one in Bangalore that I was talking about, top right. Okay. Bottom left, this is dal packaging. Dal packets are picked up and put into a sack. This is in Chennai. And you see, small SMEs can afford to use something like a cobot. Okay. They may not be able to put a robot in. They may not have the skill set to handle a robot on their plants, but a cobot, if you know how to run WhatsApp on your cell phone, we can teach you how to run, because this lady right here, bottom left, she was telling us, hey, the robot and all, I don't know how to operate this. We said, do you have a cell phone? She said, yes. Then you take this little teach pendant that I have and I'll show you how to move this robot. Today, she's programming the cobot. She's so proud of herself, So anybody can program a cobot. You don't need a robot trained person, which is where the value of this comes into the SMEs in India. I think I see a few doctors in the audience, probably university professors. I think there are many students here. Top left, that's in PSG College, Coimbatore. You know, they're using the cobot for welding applications and other things. The professor and head of department, Dr. Vinod, is talking about it here. What's most important is, you see here's a student, she's talking about, the cobot can be put on a trolley like this and moved to department, right? So if you're wondering, I can't afford this, well, you can have the electrical engineering, the mechatronics industry, and then the SME chamber that you've got, move the cobot around, and now if 3 of you are sharing it, you can easily afford a cobot, which is exactly what PSG College did, okay? You notice how they move it around from lab to lab. One person. Top right, that is IIT Kanpur is doing the Amazon Pick Challenge. These are all very smart engineers. They don't want to do the programming like I told you on the touch screen. These guys know Python programming and high-end programming. Well, they said, you just give us the robot arm. We will work with Amazon to do picking up random parts, a little artificial intelligence here, right? So PhD projects can be done in universities. Bottom left, this is a school in Ohio, which trains students, you know, how to do automation. So you can see all the students are working safely, learning how to program cobots, that's the skill required in factories today. Bottom right, a little more complex thing put together by one of our partners in Germany. Here they're doing a 6-month course in a university, teaching hydraulics, pneumatics, robotics, all Industry 4.0 stuff on one little bench like this, okay? And some more things like, VIT, Vellore Institute of Technology, Manipal, all these people are using cobots to teach students with the next level of skills, right? So if you're a university, you can't do without this, frankly, okay? This is something that is very important for your PhD programs and those kind of things, okay? Even for teaching undergraduate students, very, very important. Safe, you don't need to worry about the student getting hurt. Then I have innovation center. So if you've got an R&D center, I've just turned off the volume here. This gentleman is talking about how they're using it in an Industry 4.0 lab at TCS, right? TCS has got this. So when their clients come in, they show them various robotic cells and Industry 4.0 and all these kind of things in their innovation lab. Okay. Similarly, this is in Bangalore, by the way. Mercedes-Benz R&D Center. It's in Whitefield. You see how many engineers they've got at the back there. This is the CEO. And these 4 cobots on the right-hand side, they simulate a Mercedes-Benz car, and they do the automatic self-parking software done in Bangalore. So you hit a button on the Benz, and it does the automatic parking, correct? Then the software is sent to the car, which is in Germany, and it's loaded on it. And but right now in India, the simulation is being done by the cobots. What simulation? It's holding the mirrors in place, where, you know, depending on A class, S class, B class, the mirrors are in different position so that I can park it. Okay. So R&D centers, huge. This is another R&D type autonomous bin picking like the IIT Kanpur guys were doing. Randomly, I put parts. Can I actually, with a vision system, have artificial intelligence to identify the orientation of the part, pick it up, and do the needful, right? So AI is another big one. This is again, left-hand side, a typical industrial robot with a cage around it. Right-hand side, a robot, a cobot handling a CNC machine, okay? Here's an example of Unilever tea bags, you know, so doing the palletizing application. Notice how the cobot is picking up a box and positioning it. And this used to be back-breaking work for somebody doing this 8 hours a shift, right? Now the cobot is doing the hard work and palletizing. Notice the box stack. It just stacks the box up on a pallet, manual pallet, and the pallet can then be removed. The end of line continues to function. A very, very popular application all over India. Unilever is our customer here, you know, ITC, L'Oreal, you name them, you know, all customers of Universal Robots to do this kind of application. This is probably another very interesting application. You notice machine tending. So in this case, I have 2 grippers on the robot. Notice that I go and pick up the bar stock from here. So if I want to run autonomous for the full night shift, I just have to load this input buffer tray with the bar stock. The bar stock is now checked on some kind of a gauging station, and then it picks it up and it goes to the CNC machine, and now it waits for the machining to be completed. Once the machining is completed, it now goes, picks out the old part that's machined with the other gripper, indexes and puts the raw part in, the bar stock. And now it comes out, the door is closed, and then it hits the button to start cycle. Okay, so OP10 starts, and now I put this into the output tray, right? So completely autonomous application. If you want to have an operator with it, you can. You have the flexibility. Okay. By the way, BFW has done this in India. For example, this is a great example in Bangalore, where one of BFW is a well-known machinery manufacturer. They've put a cobot like this, and one of their SME customers is doing this in Bangalore. Okay. So he's using this technology. Anybody who has an interest, talk to us about this. They're a fantastic company to deal with. Great CNC machines, and you can automate it so your production is not so dependent on human beings. Okay, and you can have much better quality and throughput by putting a cobot in there. Okay. All right. So that was an example of right here in Bangalore. I think this is in Pune or someplace like that. Okay. Now, one of the important things here is remember that this is one of the 50 disruptive technologies of our age. Okay, Frost and Sullivan has talked about 5G and blockchain and AI and all these things, but in advanced manufacturing space, you see collaborative robots is one of the top 50 disruptive technologies. So if you're an SME watching this thing today, and you're thinking, how do I get started on my road towards Industry 4.0? Well, do you want to use 50-year-old technology like robots? Or do you want to use technology that's disruptive for the next 50 years? This is the technology that's going to see you into the future. Okay, so it's very important you make the right judgment, you make the right decisions. You won't see robots in this, but you will see collaborative robots are a huge way towards harnessing the future and being competitive in the future. Industry 4.0. Since this is an Industry 4.0 session, what is the definition of Industry 4.0? Well, it's a very complex definition of 26 things by this consultant called McKinsey. I'm just going to break out one: human-robot collaboration. Okay, so if you just manage to put 20 lakhs aside, you can manage to get funded for 20 lakhs, put a cobot in, you, an SME, have started your journey towards Industry 4.0. Because the definition of Industry 4.0, one of the definitions is human-robot collaboration. Okay. In fact, people like Nokia, who are our customer in Chennai, they've launched a campaign on pioneering Industry 4.0 in India. And what's the picture that you see in the middle? You see a picture of a cobot. You know, so yes, Nokia is doing hundreds of things to do Industry 4.0. But the fact that they are doing the automatic screw driving, nut running, using a cobot, they've highlighted there as one of their Industry 4.0 initiatives. Okay, so if Nokia can do this and say that here I'm pioneering Industry 4.0, I guarantee you any of our SMEs who want to just invest 20 lakhs can actually start their journey towards Industry 4.0. Okay, here's an example of manufacturing into the future. It's called human robot, human robot, human, you know, in an assembly line. MIT has done a study, Massachusetts Institute of Technology, that when humans and robots work together, there's an 85% reduction in idle time, 85% improvement, okay, in your performance and your productivity. So therefore, the benefits you get with the cobot, firstly, it's single phase. You know, there's a cobot running behind me. Hopefully you can see it. This is in my house. I'm in my home office. Okay, I can bring it to my home, put it in my car, carry it around. That's how flexible it is. All right. So it's easy to program. Like I said, if you can program your cell phone, we'll teach you how to program this. It can, every axis can run plus or minus 360, every axis, which means there's no blind spot. I can operate in very confined spaces. I can move it around from place to place, you know, and I can mount it on the ceiling. I can mount it on the machine. I can mount it on the floor and have very, very little power consumption, something like a light bulb. Okay, so here are some of your benefits. There's 65 patents built into it. and over 46,000 deployed. So now take a look at some applications, like on the top left in Bajaj, screw driving. Notice screws are being picked up and the screw driving, the nut runner is there, is being positioned. And here's another case. These women are working on the assembly line because Rahul Bajaj's vision is to have 50% of his assembly line should be women. Equal employment. There's more opportunity of hiring women today, right? So women find it very easy to work with cobots because your physical strength is not required, So here the cobot is doing the nut tightening, bolt tightening of the engine blocks, Top right, this is in Peugeot, France. Very similar. Top left is India, that's France is up there. Notice that the cobot is going under the belly of the car and tightening bolts there. Here, a human being would have to be on the floor, very uncomfortable throughout the day to do that kind of job. The cobot is now very efficiently doing that. Okay. Bottom left, that's Shruti Engineers. Notice it's a small SME, and he is now taking the parts that he's manufacturing here. I think it's a leak testing machine. He's been loading and unloading parts, into a machine. Bottom right is Udayam Dal. Hopefully you can see the video. It's just picking up the dal packets and putting it on the sack. Her job now is only to drag the sack out when it's ready. Put a new sack on the left side. So her job has become much easier. Before she had to carry each of these 5 kg bags of or 3 kg bags of dal and put it in the sack. Okay. So here are examples. Like I said, big companies, small companies, cobots are the big equalizer. So if you're an SME wondering, can I do this? Take a look at these videos. Yes, you can do it. Okay. So the two important concepts here are partial automation and flexible automation. So Elon Musk, he put in a lot of robots, and he found that by putting so many robots in, he lost flexibility. They were trying to make 5,000 vehicles per week, but he ended up making 2,000. Elon Musk, the great Elon Musk, one of the greatest men in the world, he says he made a mistake. Yes, excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated. So what is he saying here? Putting too many robots, you can become too inflexible. I have to have a blend of humans and robots working together, which is what I call, or my company calls, partial automation. Okay, and partial automation is great for India because we have so many people. So in this case, you notice that the bottles are being collated. It's being put into a box, correct? And the human being is keeping the box open. Human-robot collaboration. I could have automated the entire system, but that would have cost me a lot of money. But I had, let's say, 20 lakhs available. So I put in a cobot like this. Okay, when I have another 20 lakhs, I can automate the other part, But partial automation to get started today without waiting too long, okay? So this is the concept of partial automation. And then finally, the concept of flexible automation. Flexible automation means I can move the robot to where I want to. So in this case, you notice that these two robots are at a cosmetic factory, and they make these little, nail polish and blush and all these things, right? It's a very, so they put the two robots on a trolley like this, and they move it to where they need. And now notice it's working with the press. Okay. So once again, I'll show you that here, as and when it's required, they move it there, put a pin to mount to locate it on the floor. And the two robots are now loading and unloading that press at the back. Okay, here they're making powder puffs. So this is unparalleled in the world of robotics, flexible automation. Okay. So if you've learned anything today, you can do partial automation with a cobot. Partial meaning I can have a human and robot work together. Second thing I can do is flexible. I can move the automation to where I need to move it within the shift. Okay. So here's Dell's comment on this. They installed one in Chennai 3 years ago. It's been operating 3 to 4 servers are picked up every minute. 1 million production cycles to date with 0 downtime. This is the kind of effectiveness they're getting. Okay. So my last slide before I turn it over. What can a cobot be used for? Answer. The cobot, think of it as a human arm, right? What can I use a human arm for? I can use it for lab analysis, for test tubes, and those kind of things. In COVID, we're finding a lot of hospitals are beginning to talk to us about this. Machine tending. You're probably an SME that's making machining parts, and you're having trouble with labor. You're having trouble with social distancing. Cobots, we say, are used for the 5 Ds. Dull jobs, dirty jobs, dangerous, dull, dirty, dangerous, difficult, and where distancing is required. I need to have 6 feet distance between people. Cobots automatically provide that, okay? Especially in assembly lines. We can do pick and place applications, quality. I just put a camera at the end of the arm and I can do quality inspection. People like Schneider from Maruti are doing it, they put a camera, and as the vehicle comes out of the line, the robot moves it to various positions and it's checking, is the radiator cap there? Is the oil dipstick there? This thing before the car is rolled out of the production line. Complete inspection, okay? Screw driving, one of the most popular applications today. It's very labor intensive to have human beings. Let's say I've got the headlights, all the screw driving to be done. Just put a nut runner on top of this hand and it can do all the screw driving for you. Best part, it won't miss a single screw. Torque will be exact every time. Injection molding machines, it can be used for gluing and dispensing applications, packaging and palletizing. Okay. So with that, my 25 minutes is more or less done. So Mr. Chandramouli, I'll turn it back to you.
Yes, that was a very, very lucid but a concise presentation by Mr. David. I think our audience would have got some idea about collaborative robots and their various conventional and non-conventional applications as presented by Mr. David. So you can formulate your questions on how it is appropriate for the Indian industry and how it is affordable by the Indian industry. Now, I hand over to Mr. Jagannath, who is a business head of M2 Next, the division of BFW. The very name sounds that he is talking about the next generation technologies. Over to Mr. Jagannath.
Yeah, good morning. You're able to see the screen?
Yes, sir. We can see the screen.
Yeah, welcome to all the BCIC delegates on this appropriate and affordable automation. And you just happen to witness the collaborative robot how it is being deployed across human mankind in all the areas. So we want to come back and talk about more focusedly on the manufacturing and how about the appropriateness and affordability of automation in the industry. So just to give a brief idea about M2 Next, this is called as M2 Next because machine to next level is the lingo which we want to follow. So that is how we have named it as M2 NXT. Just a brief portfolio that we have 3 divisions: factory automation, process engineering, and additive. In factory, we deal with both the virtual as well as physical, which is digitization, digitalization, and digital transformation, including automation consisting of gantry, assembly, robotic, AGV, and so on. And a lot to do with process and additive, which is catching up very fast. The entire organization revolves around Industry 4.0. Today, we are going to look at Atmanirbhar Bharat, a declaration done by our Honorable Prime Minister, how we are going to take this opportunity in this pandemic situation and see how we are going to go really, very high on the manufacturing sector. And looking at the current demography, there are a lot of shift happening on manufacturing from China over to India. The last one or 2 months, we are seeing a huge drift of plenty of auto components coming in, manufacturing parts requirement coming up. So it's the right time that we start looking at the industry in terms of Industry 4.0, that too more so to do with COVID compliance. So quickly, let me come back on Atmanirbhar Bharat. We have something like a device called as an IRIS, which stands for Intelligent, Reliable, Innovative, Seamless, which is a digitalization device, digitizing device which can sit on any equipment. This was launched in 2017 under Dr. APJ Abdul Kalam Center R&D, BFW Bangalore. Can connect to any generation control on the shop floor. Just to give a background, we have already connected 250 machines already. And this is a fully homegrown product, conceived, designed, developed, and manufactured here in Bangalore, wherein we can work on 100% flexibility of adapting this device on the shop floor. Now, as Mr. Chandramouli gave a very good introduction talking about it's not digitization or digitalization and automation are two independent things, but they go hand in hand. And how are they relevant? How are they going to become more and more relevant in the today's context is something which we are going to talk. And to bring in that kind of substantiation, here is an architecture where we talk of an intelligent device or an Industry 4.0 device, active device, which sits in the shop floor, which can start talking to almost every equipment on the shop floor, be it a machine tool, be it a gauging station, be it sensors, operator, robot, you name the device, including the crane, including the press, whatever you have, the device needs to have an adaptability to start converting every equipment into a digital equipment so that you start getting the information. And essentially this device, is an edge computing device where it not only acquires the data, it processes the data and then transfers this data into the cloud in encrypted packets to meet 100% data security as well as data integrity, wherein despite cloud issues, despite connectivity issues, the data is not lost. So this device, today is becoming more relevant than ever, that based on the current pandemic situation, the uncertainty of skilled labor coming into the manufacturing shop back when the demand has suddenly risen and there is a lot of vacuum and gap, and again the sustainability of the market is becoming a big question mark. So in this condition, the device which we conceived, designed and manufactured has become very handy, where I'm going to talk about the applicability of this. So quickly getting into, I'm going to talk about 3 case studies today, particularly keeping MSME in mind. The first case study is going to be the digitization of every equipment on the shop floor, how an Industry 4.0 is going to be an MSME and advantage and yet affordable. In the sense that today when we really want to go worldwide, exporting components to all over the developed economies, first question what would be asked is the quality and the quantity. Quality is what kind of deliverable you have in terms of 100 ppm, 10 ppm, 0 parts per million, what kind of quality you have. And quantity is that how sure are you to deliver the parts or the product based on the order without having any reason of failure. So this is where digitization is going to take really a hot seat, and we are going to look at it how this is going to be lot more deployable than the current perception that it is expensive, it is not possible for us to adapt, and so on and so forth. The second case study is going to be the automation in terms of appropriate and affordable automation, where case 1 is with a 2-axis CNC gantry on a turning center, because turning center forms the lowest cost per hour in the manufacturing shop floor. So how does an automation become affordable and appropriate with return on investment calculation, including the Industry 4.0? So here is where automation and digitization are going to talk to each other and give a full benefit and advantage to the manufacturing sector, be it small, micro, medium, or tier 1 or the OEM themselves. It's going to be really a good case study where we can look at how things are being shaped up here. The second case is again automation with case 2 with robot. Here the investment is high. We are going to talk about this case study where the investment is going to be high, but the beauty is the return on investment is dramatical in terms that the return on investment as compared to case 1, in case 2 it's going to be 50% faster, which makes the manufacturer not only competitive, but also will have an edge over his competition, not in the country but worldwide, while you still have Industry 4.0 compliance on the cell. So now let us start looking at each of these 3 cases today, and let us examine like what kind of advantage and benefit and affordability can be met. Now, first, let us talk about the digitization case where, a device, an Industry 4.0 device, IoT device, which I just spoke to you, can come on any machine tool, on any, I have taken a lathe in this case because that's the lowest supply, lowest value in the supply chain, that this can be plug and play device where you can use it on an existing machine. As this device comes with an internal modem along with the SIM fitted on the iris device, you can connect this, mount this device and hook it up to the existing CNC at the site. And instantaneously, the moment you give 220 volts to it, it will start communicating with the cloud. So what happens is you can start running the machine, and the entire connectivity of this device on any of the existing machine with any of the control, be it Fanuc, Siemens, Mitsubishi, Haas, Mazak, it can be any control. The moment you connect this, because it has an internal modem with IoT SIM, and it is ready to take up the connectivity into the cloud. So the data starts instantaneously flowing into the cloud. Now, the moment this happens, now let us look at, now you start getting the data like what is the productivity, what is the consumable timing, what is the breakdown timing, what are the typical issues on the machine, what kind of productivity was achieved on the machine. It starts communicating with the cloud. And this data is going to be available at the fingertips of the owner in case of an MSME, where he can just log in into his mobile and start looking at what kind of productivity levels are being achieved on the machine, and what kind of numbers are being produced, and what is the cycle time, what is the loading unloading time, what is the lunch break time, what is the tea time, how much is the machine stopped, and has the machine stopped because of there is a breakdown or the machine is paused, so on and so forth. Now, when we look at the return on investment, today you can see that when you put in this device, the return on investment is just 12 months for a digitization program. So I have just listed down some of the actual costing, where when a manufacturer or when an MSME goes in and buys this device. So in this case, the 4.0 device, what I was just talking, plug and play, costs about 99,000 rupees, and a cloud charge of 24,000 rupees for 12 months. And when you are making an investment of something like 1,25,000 rupees, also taken an interest cost at 9% per annum, which is about 8,910 rupees. So the total investment cost, we can aim it as something like 1,31,000 or 1,32,000 could be the investment cost. Now, how do I get the return of investment? If you see on an 8 to 6 inch lathe, if you look at with a cycle time of 35 seconds, I've just taken an average cycle time of 35 seconds. Here, when you look at a 35-second kind of a cycle time, of late what we are witnessing is the operator turnout, or the operator moving from one organization to another organization is very fast, because of almost 2 times loading and unloading by an operator in a minute, which is very, very, back-breaking, the word what was used by Mr. David. I would like to use that word. So traditionally, you would be producing something like 2,160 components in 3 shifts. This is what I've taken it on a 3-shift basis, because the MSMEs usually work on 3 shifts when they get good demand. Now, the moment you put this device and you start monitoring this, what we have seen is a minimum of 5.4% on an average. You start looking up at your productivity. The productivity actually starts going up because you start getting to know what exactly are the timings which are being lost. So you can have a simple increase in productivity from 2,160 to 2,277, which is 5.4% up. And if I just take a 3 rupee 40 paisa as the margin, what you would earn per component on an average, you will be earning about 1,19,000 rupees. And you can also take a depreciation benefit of about 13,000 rupees for the investment what you make on 1,31,000 on your books, which brings in a return on investment on the 12th month. So here we are talking of a 5.4% increase in productivity targeted, which will give you a 12th-month return. But the beauty is that it is a habit and a culture. When you start capturing each and every trait on your shop floor, in fact, your productivity can start improving month by month and then quarter by quarter. And we have seen at some of the customer place, they have gone up to 12%, 13%. So which means that you not only get to know what is happening on your shop floor, but you also get a productivity improvement. And when we are talking at such a low supply chain kind of an equipment where you can witness an increment, you can witness a return on investment on 12 months. You can see that if you have a machining center, if you have a grinding machine, or if you have a combination of machines, you can see that how the return on investment can be much, much faster than this, which makes, not only that, when you start looking at the productivity, and if you start integrating a gauging station to this, which has the capability, you also start getting the SPCs and the SQCs, and your trait of 100 parts per million or 10 parts per million can be easily visualized, and that can become a commitment, part of the commitment for the component supply to the next level or the next customer. So this is one case study where, I would be looking forward for many questions at the end of this session. The second case, very similar to this, which we did a proof of concept for a 40-ton press, where, particularly the operator, when he would run this machine in the third shift, would simply run the machine without inserting the component between the punch and die. And the mechanical counter on the machine would always show the number of parts which were produced. But while the total productivity for the week or for the day would always be much lower than the mechanical counter. So a simple retrofitting of a vibration sensor, which could capture amplitude and vibration in all the three vectors. We did a small trial and a proof of concept on a 40-ton where the component size was thickness was 0.125 millimeter and a 0.2 millimeter, and we could see a difference of 150 to 200 micron amplitude difference, which we could logically conclude it in the edge computing device, that is Iris, to make the component present or not. Now with this, the moment we started integrating this, the return on investment was so dramatic. It was 3 months and the productivity jump was almost 25%. So what we are talking today is, it although appears like 1.3 lakhs is expensive for a machine of 15 lakhs or 20 lakhs, which is probably 10%. But when you look from the return on investment and the deliverable commitment from the perspective of quantity, and when you have quality gauging associated with that in terms of quality, it really becomes very affordable. You become competitive, and you can also start getting better throughput, wherein you really become competitive in the market. Now let us take the second case study. So here again, I've purposely taken turning center as this 6-inch chuck machine is the lowest value in the supply chain. So let us look at a CNC gantry and the machine for loading and unloading. And again here, digitalization and automation association, going hand in hand. What kind of double whammy benefit one can get by having a look at it is something which is really very, very commendable. So the requirement is, you have two machines, you have one operator running this, or you have two operators. I have taken for simplicity one operator running this. How do we get into automation and Industry 4.0 here? So typically we arrange the machine this way, side by side. You have a gantry on the side of the machine, and if the component is not, we have taken a component weight up to 10 kgs here. So you can use any type of up to 10 kg component with a 6-inch chuck. And the floor space is not really very big. In case if the floor space is a challenge, we can even mount the column of the gantry by the side of the bed or on the bed itself, and still have the same footprint as two machines what it would take. And the entry and exit of the component will be from the top. And this can run 24 hours with an input and an output conveyor mechanism. So let us take a look at the video. Although this is a single machine, I would just like to show you the video.
Jagannath, sound is not coming, so you can give a running commentary. Jagannath, there's no sound on the video, so you can give a running commentary.
Yeah, so you can see that the component is being, it's a twin gripper where the component is the finished component is unloaded first and the raw component is loaded here. The loading unloading time, if you see, it is not more than 12 to 13 seconds. And since it is coming from the top, the interlock for turning is really not required. So it can be instantaneous. And since it is going from overhead, you can see that the space occupied for the automation is very minimal. And this can go on as long as one helper is available to load the raw component and pick up the finished component. So you can even see that inserting the component with an axial movement of the gantry is possible. Orientation is possible. A tailstock coming and holding the component. So various kind of options on the turning center, which could really take longer and difficult for the operator to run throughout the shift. So again, here the poka yoke of component being present and how the conveyor stops and the part is being picked up. So you can see that the entire thing is handled within the machine footprint, where outside the cell, the helper needs to come and pick up the finished component and load the raw component. So there is no opening or closing time of the guard. There is no such thing. Everything can be concurrently programmed. Now let us come to the return on investment calculation. In this case, being the lowest, it takes 30 months for this kind of an automation. So once we start looking at the price of a 2-axis CNC gantry would be around 16,50,000. Input conveyor and an output chute is what is being considered in this calculation, which is 1.5 lakhs. And Industry 4.0 remote monitoring, wherein it gives you the performance of the cell, the number of components produced, what is the takt time of 2 machines, what kind of loading unloading time is there, what kind of breakdown is there. You can get all of this on your fingertips on your mobile, irrespective of where you are staying, as long as you have a internet connection. So it has an Industry 4.0 compliance. I've also considered a warranty extension from the 13th month to 30th month. Usually the equipment has a warranty of 12 months. So some cost for it. And the interest on investment for 30 months at 9% is about 1,71,000. So put together, including a helper cost, is about 23,71,000 is what you see. So if you look at a cycle time of 35 seconds, and when we map this with respect to 21 hours what an operator runs and 23 hours of what the cell can run very, very successfully, you see an increase in productivity from 2,160 components to 2,366 components. So if you compute 3 operators' salary of 16,000 rupees per month for 30 months, you save about 14,40,000 rupees. And an increase in productivity at again 3 rupees 40 paisa margin per component will give you on 30 months 5,25,000 rupees with 8.7% increase in productivity. One can also take the depreciation of this investment on 23,71,000 on their income tax when they file their returns, which is about 4,08,000 rupees. Or a decent running cost of the gantry, including the power, pneumatics, oil, lubrication, so on, about 57,000 for 30 months. So you get on the 30th month, the investment, return on investment. Now the beauty here is you don't need a qualified operator to run the cell, number one. Number two, you can have one helper running around 4 to 5 cells at a given time, which means if you replicate 8 machines or 9 machines or 10 machines with 4 gantries, different gantries, you can have one helper running around. So your COVID compliance is already automatically met, and it runs 3 shifts. And if you have demand, you could also go in on a Sunday, whereas our computation is on 25 days per month, wherein you can run for 30 days with one helper coming in and loading the raw component, wherein the return on investment is going to be faster than this 30 months. And then if you associate a gauging station with this, you can start talking about the quality and quantity deliverable and really become competitive looking at the world market in terms of component supply. And one can start graduating himself from a better value in the supply chain when one starts getting the taste of automation. Now, this was about case 2. I look forward for questions. Now The last case, which is the third case, we are going to talk about robotic automation. Again, gauging IoT device on the machine, on the cell, the robot, and the machine tool itself, and different types of machine. And the component is going to be really heavy. We are looking at something like a continuous productivity, 100% safety on the manpower as well as on the equipment because of the nature of the component, what is there, which is weighing about 30 kgs. So, and an entry and exit into the cell is through biometric, which is controlled by the IoT device, which can even track who has entered, who has exited the cell, what kind of things. So there is all the data exchange happening between the robot, between the machine, between the gauging station, and between the device. And everything can be viewed on your fingertips using your mobile device or a laptop or a tablet at any given point of time, at any corner of the world, as long as you have an internet connectivity. So let us take a look at this third case. So here we have dealt with 3 industrial robots, job weighing about 35 kgs, very difficult to handle by an operator. 8 different machine tools. The machine tools are vertical turning centers, then drill tap centers, then facing and centering SPM. The component comes through an input slat conveyor, and output palletizing is automatically done by the robot. The cell and machine is being monitored through iris device, which will talk about the performance of individual machines, the takt time of the entire cell, and the cycle time of each machine. Biometric entry and exit into the cell, depending upon the tool setter requirement and depending upon the maintenance requirement. This can be easily pre-designated and approved so that randomly anybody cannot enter if they have a key, or duplicating the password and entering is not possible. Entire cell and machine performance can be remotely monitored. So this was one of the implementation what we did before moving it into this is a brownfield project where we did this implementation prior to moving it into the site just to run and see. So here if you see this particular cell, although the component weight is 35 kg, here 0 parts per million is the commitment from the cell throughout its performance. There is an automatic gauging station, and the gauging station gives a tool wear offset feedback back to the right machine, right controller. So the wear offset is automatically corrected on those machines so that your SPC and SQC is met when you do a statistical analysis of CPK and CMK. And the rejected component, and there is a family of components which are being run. There are about 5 different types of component running in the same cell, where we have POCA yoke to check for the right component coming into the cell. And by whatever reason, if the operator loads the wrong component in the cell, the component is clearly rejected by the robot and moved it out of the cell. Now this the only requirement here is a helper to load the component at the input stage and a forklift operator to pick up the component at the output stage to the pallet. This is the only requirement. And you need a tool setter to come and keep on changing the inserts of all the machines, because the casting is so hard that every 15 components the tool wears. So which means that on a round robin, every 1 hour you need to change the tool inserts on each machine. Now we come back and look at the benefits here. Is an unmanned cell operation with auto tool offset correction, auto gauging, auto palletizing, tool life management. Cell can be remotely monitored for its OEE, plan versus productivity, statistical quality control, personal entry and exit into the cell. Then 73% reduction in skilled manpower, where you can use them for other intelligent purposes. Over 90% OEE accomplished, 0 parts per million. Safe operation of the equipment and human, cell access only to pre-authorized and personnel through biometric. And you can virtually trace all the machine components on the pallet, because the robot knows which component at what point of time with what inspection result is placed on the pallet. So you can practically trace the component without having any kind of device like RFID or barcode or any of the traceability devices on the component. Now let us come and take a look at the return on investment. So here the cell appears or perceived that it is very expensive when you automate this kind of a cell. But then if you look at the return on investment, that it is just 12 months for 8 machines and 3 robots. So if you look at the investment cost, the robot with peripherals would cost about 95 lakhs. The conveyors and palletizing would cost about 40 lakhs. The remote monitoring of Industry 4.0 for all the 3 robots and 8 machines would cost about 12 lakhs. Automatic gauging about 13.5 lakhs. And if we apportion the interest, what one would lose for 12 months, on a rate of 8 or 9%, about 20,97,000. The total investment cost would be about 1.76 crores. This is the investment cost. Now, the first reaction by manufacturing small scale fraternity would be that it is not affordable for us. It definitely we should not look at it unless you are in tier 1 or you are a OEM. But look at the returns on the 12th month and look at the kind of cycle time and the productivity improvement. Now, this is a real classic case that 450 seconds is the throughput or the takt time of the cell. So with the changeover from manpower, because the operator salary, you can see that there are 24 operators who are being replaced here, including the supervisor and the helper. So the salary benefit is about 30,72,000 for 12 months, while the productivity improvement is going up by 25.6% here, which is from 238 components to 320 components per day. And if you take, because it's a heavy component and it's at the fag end of its manufacturing, the margin for this. If you take the depreciation for this, it would be about 21 lakhs, and the running cost of the robotic cell for 1 year is about 8,02,500. So on the 12th month, you clearly get the return on investment, and then you see the subsequent, performance with respect to competitiveness and with respect to the delivery commitment and the quality commitment is going to be humongous. So from that perspective, when you start looking at this kind of an automation, where currently today the financial sector is opened up for giving good investment support, one need to look at it, and truly if you start improvising from this stage, the productivity can really touch to 30-35%, and you can truly become globally competitive in terms of deliverable, both in quality as well as quantity.
Jagannath, I think we are exceeding time.
So with this, I come to the end of the presentation. Yeah. So we have one last slide which talks about the AGV. So here again, we have done a small proof of concept where we have run the AGV for 27 machines handling in a given cell, given a plant, which is delivering a particular component to North America, where the delivery commitments are very high. So keeping the COVID situation, the AGV which is designed and developed, we have done a proof of concept with 2 AGVs handling 27 machines, where the part movement right from the input hardened stage till the output quality and packing stage, the AGV has been conceived and the proof of concept is supplied, but we are yet to implement this. So again, if you see the return on investment here on this particular subject is less than 12 months. So with this, I come to the end of the session. So let's boost productivity, performance, and as a result, profitability. Thank you for your attention. Over to you, Mr. Chandramouli.
Okay, it was a very interesting multiple case studies of showing the return on investments. The affordability and the appropriateness is clearly addressed by both the great speakers. And I would like to now ask a few questions with your permission. And I would like to go to because everybody should see the questions. I have, before we take the questions from the text box, some of the questions are also from the text box. Hello? Hello, are you able to see my slides?
Yes.
Yes, sir.
Yes, sir, we can see, sir. Please go ahead, sir.
I'm getting some disturbance. Okay, the first question I would like to ask, Indian entrepreneurs are generally apprehensive of investing in automation and digitalization. Mr. David, how would you motivate the Indian small and medium enterprises to invest in automation and cobots for the first time? And Mr. Jagan, how will you motivate the Indian small and medium enterprise to invest in automation and digital transformation? So there are two parts of this question. automation with respect to cobots and automation with respect to digital transformation. How will you convince?
Yes.
I know you touched upon some case studies. Let us go to Mr. David for answering this.
Yeah, so I would like to actually take a case, a specific case, just to explain that, how an SME made the journey to start using cobots. So I'm actually going to share my screen here.
Oh, then I will unshare it.
No problem. It will still share, not an issue.
Oh, is it? Okay.
Yeah. So. Okay, so
yes, your slide is coming. Yeah.
Just a second. I'm sorry. I may have done the wrong one.
Let us come. Continental India?
No. I think I've shown the wrong. Just a second. 1 second.
No, take your time. Take your time.
Is this one showing now? It's like a video. New engineering work.
You have to make it to the full view.
110 सालों से रह रहे हैं। आज हम जिस फैक्ट्री में बैठे हैं इसका नाम है न्यू इंजीनियरिंग वर्क्स।
Yes, Mr. Agarwal is speaking.
Yeah. So what? I'm just putting it on mute, but just to show, this is a little shop in Jamshedpur that decided to use cobots. He had come to the Impex.
There is a screen of yours which is hiding, sir.
There's a screen that's hiding. Okay.
There is something in your name. You have to remove that. Now it's gone. Yes, sir.
Now it's gone?
Yeah. Go ahead.
Now you can see it?
Please proceed. Yes, sir. Full screen.
Okay. So in this particular, it's a company in Jamshedpur who makes parts for Tata Motors. It's a commercial vehicles, Tata Motors. And he came to Imtex and wanted to understand, how cobots can be used in a machine shop like this, right? So this is his machine shop. As you can see, machines are very close to each other. Space is an issue, right? And I'm just going to go a little fast. You can see the little components he's making. He has now put a cobot in here between two machines, right? One servicing this side, one servicing the other side. Now, this is his son. So it's his father-son combination that did this. Notice how cramped the shop floor is, right?
But your video is not moving, sir. Your video is not moving.
Okay. I'm actually maybe skipping a little fast over it. What I'm going to do is, can you see now the lady working?
No, sir. Only the chairman first screen is on. You have to unshare and share again.
Okay.
No. You can see, sir. You can see.
Sorry?
Only chairman is coming.
Okay. Sorry about that. Okay.
We could see the video, sir.
Sir, we can see, sir. The screen is
please proceed. Maybe my problem. Okay, go ahead.
Think, your screen is frozen, Mr. Chandramouli. But
my problem.
Yeah.
Sorry.
So basically, what's happening in this particular case? How could he afford 30 lakhs for this particular investment of putting one robot in between two CNC machines, right? So if you see the calculation that he did, he has 3 machines for 3 shifts, and he pays his people 10,000 rupees a month times 12 months. And there's an increment of about 10% per annum. So year 1, had he not put in any robots, would have been about 10 lakhs to run this particular machine, right? 3 shifts a day. Year 2, it would have been 11.88 lakhs, and year 3, it would have been 13 lakhs. The project that we supplied him cost about 30 lakhs. So in year 1 itself, because he put the cobot in, he took a loan for 30 lakhs, paying a 15% interest. So basically 4,50,000 is what he ended up paying as interest. His depreciation benefits 15%, 4,50,000. So the cost that he incurred for this project was actually 9 lakhs, as opposed to 10 lakhs 80,000 had he just got labor. Okay. Now in year 1, the labor cost would have been that much, robot cost was so much, but he also had a productivity boost because instead of running 21 hours a shift, a day, he was able to run 23 hours with cobots. His quality went up, very modest thing. So basically in year 1, his total benefit was 10 lakhs and 30,000. Notice that he would have paid 10 lakhs and 80,000 had he just gone with standard labor, with nothing to show for it in year 2, right? So there was a positive cash flow for him in year 1 itself. Year 2, year 3, etc. was basically gravy for him. And in fact, this was so successful, right? A small SME that his bank actually told him, why don't you put 6 more robots in there, because you are making so much money by putting this. Okay, so the bank started pushing him that, hey, you need to put in. So now today he's got 10 cobots when he was hesitating to put in 1. Okay, so it just goes to show that if you take the first step in, right, the benefits are amazing. So just one more slide of the various videos that you can see of cobots. It's been a while since you've seen the videos. Whether it's glass handling, whether it's dispensing, whether it's inspection on the right-hand side. You can see there's a camera looking at the treads of a tire. This is Jeff Bezos, the richest man in the world, playing with haptic gloves, right? He's able to control the robot arms with gloves on the end of it, right? So if you're handling a COVID patient, if you're handling uranium, let's say, right? Bottom middle, you can see this is loading and unloading at Bosch, who's very highly Industry 4.0 compliant, right? And finally, at the bottom right, you see that there's an AGV with a cobot on it that's doing screwing for an Airbus wing, okay? So very simple applications to very complex applications can be done. And each of them, the ROI is extremely compelling, in some cases, even less than a year, okay? So the question I would say, Mr. Chandramouli, is not can they afford it, can they afford not to do it? Because this will ensure that your business stays competitive and your doors are open.
Oh, thank you. That's very, very convincing. Let me move on to Mr. Jagannath with a similar question, but focusing on digitalization rather than automation. Digitalization. Jagannath.
Yeah. So,
how will you convince a small and medium enterprise that it is worth going for digitalization?
So, as already shown case study, so one needs to identify the most.
Summarize the case studies.
Yeah. So the bottleneck equipment on your shop floor.
Can you come on the video? I want to see you.
Because that may slow down the.
No, it won't slow down.
One needs to look at the bottleneck equipment on the shop floor, which is governing the throughput of the productivity of the entire shop floor. So if you happen to map that and start looking at, what target I need to achieve by improvising this, if you can simply map that, adapting a digitalization device and then bringing in the monitoring part there and slowly start including the sensors, the gauging station, and other things which are part of the bottleneck equipment operation. It's always less than 12 months is what we have seen in digitalization. It's always less than 12 months. But the biggest apprehension what the MSME has is that whether I will be able to adapt this on the shop floor and whether the skill set required in the team who are working there will be able to do so. That's the apprehension what they have. But now, since the technology has become so simple, plug and play and easy to handle, I think, the more and more customers get into the commitment of demand and supply, I think it should not be an issue. So currently the situation is that the sustaining of the productivity is a question, but then once the market stabilizes, I think with return on investment less than 12 months on digitalization, it is always easy. But then the MSME need to accept this. So that's where I would come.
How many of your Cobos, Mr. David, is now, how many Cobos are on small and medium enterprises in India?
I hard to get a number, but I would say just something like around over 25 that I'm aware of in small and very small companies, like even with just 10 machines.
Yeah. 25 case studies.
Yes.
How about medium enterprises?
That will be much larger numbers. So, it'll be in the hundreds. I'm not sure the number, but yes, in the hundreds.
So there is a lot of inroads into that.
Yes.
And Jagannath, how many companies you would say in India have gone for digital transformation to some extent in the journey?
Yeah, in the journey we have, like if you look at the tier 1 and OEMs, I would say that like about 40 to 50, but there are many who are working on it. Many are working on it. So there is a very, very large scale comprehensive study what they're doing, how to connect the shop floor to the ERP, how to connect the supply chain. They're doing a lot of things. Like, for example, the number one motorcycle manufacturer has done a fantastic job in the new plant which has come up in Chittoor. If you happen to see that, every machine will give a trigger saying that what exactly is happening, including the the elements which are part of the machine, the peripherals which are part of the machine.
So the other day you mentioned to me that there is a sudden surge of inquiries.
Correct.
The automation and digitalization industry.
Yeah.
That brings me to the next question, Jagannath. For want of time, I want to move on. The pandemic has disrupted various industries to various degrees. Yeah, the COVID pandemic. So both of you, I want to ask similar question. How does the corona accelerate the adoption of automation in India? And how does the corona accelerate the adoption of Internet of Things, as we call cyber physical systems in India? Mr. David?
Sure. Yeah, actually, I've put one slide here to explain this. And what I'll do is... Okay, can you see the slide? Combat COVID with the HRC?
Yes.
Okay, so this addresses how has coronavirus helped the adoption of cobots. So there are four distinct answers to this. Number one, social distancing, right? It's now mandated in factories that you have your 6 feet or 2 meters distance between people. So the example I have here, you can see there's a woman here, you can't see the other woman, she's 6 feet away, and a cobot is in between, right? This is the exact example that Dell gave us, that they had an application where they had to put Dell servers into a box, right? So a human being was carrying a server and another man was having the box with these styrofoam. These people were breathing into each other in the same space, right? Because of cobots now, that application is not possible today under COVID laws, right? So today the cobot is actually holding the Dell server in place while he puts on the end caps. Okay, the operator puts on the end caps, and then the cobot then lowers the entire server into the box. So an application which is not possible because there are too many human beings involved is now possible. So COVID is accelerating the use of robots where social distancing is imperative. Number two, quick deployment and flexible redeployment. I gave you examples of moving, because of COVID, most people's, their orders have been reduced in size, so no longer are they doing 24-hour production for one particular part. So a machine set up maybe for one shift and then another shift, they're doing something totally different, right? Here, more than ever, the flexible redeployment of tools is critical. I need to move it from this machine to that machine or this application to that application. So flexibility is the key today with COVID, right? That I can respond very quickly and for small order sizes. Finally, democratized automation. The fact that, like Mr. Jagannath also mentioned, many people, SMEs particularly, are worried. Can I handle this technology? Can my people handle it? Or am I going to be stuck with this expensive investment that I can't make use of? Well, the fact is, as you can see, these pictures are actual workers that were operating before the cobot and are operating with the cobot. They are now become friendly with the cobot and the cobot is their tool, right? So the fact that you are raising the status of your workforce, right, while at the same time getting the benefits of productivity and quality is a great combination. And the very final thing, partial automation. No longer can people hide behind the fact that I don't have money to automate. Well, no problem. You've got 5 people there, you keep 4 of them and put a cobot in, or you remove 4 and put 1, The fact that 2 can work together, I don't need total automation to get started, is a very powerful concept, particularly during COVID, where budgets are limited.
That's fantastic. So there are at least 4 benefits arising from this. Mr. Jagannath?
Sure.
Yeah, so looking at the case studies, what I showed in terms of automation, I think there is always a possibility, the return on, you need to look at from the return on investment, which I suggested. And, again, adapting with, there are simple techniques like if the batch quantities are very high, you can always bring in the family of components and have a quick change.
I want a specific point regarding Corona and the acceleration by the Corona, Jagannath.
So here, if you see, for example, when I said the 20 component buffer per cell, what we are talking. So if you take the 20 component, which is a 20 minutes buffer, 40 components, 20 minutes buffer. So of 8 machines, you will have 1 helper who would be loading the component. So which means that you are completely eliminating, you are already automatically maintaining the social distance there. So the number of operators who would run the cell, if you see a cramped shop floor, which David showed, if you put in a gantry there, instead of having 8 machines and 4 operators, you will have 8 machines and 2 gantries and 1 helper. So which is automatically COVID compliant. And over and above that, you have IoT coming up to the supervisor or the owner, showing that what is the output from that cell or the line, which gives a lot of peace of mind. Like everybody sitting at home today and looking at a webinar, he can also look at his mobile and say, my cell is running and up and running, so there is no issue. So you are guaranteed about the performance. I hope I have clarified.
Oh, that's fantastic explanation, Mr. Jagannath. I think what is very, very clear, that while people have been waiting and watching over the last 4 years about Industry 4.0, whether it is automation or digitalization, the corona in a positive way, while none of us want to be positive in corona on the lighter side, we want to test negative. But there is a positive impact of the corona, and even Government of India, I'm aware, is trying to push for Industry 4.0 technologies. And that brings me to some of the questions. It's now 12:30, 12:45. Our President of Bangalore Chamber is joining us, along with Vice President and Senior Vice President, to thank all the speakers. But in the 15 minutes, I have some interesting questions. I'm trying to combine the questions without mentioning any names thereof. Today, we have 150 participants, which is one of the highest so far in the history of this Industry 4.0. That itself shows the amount of interest that people have. So there is a good combination of industry and students. One of the interesting question is a technical question, never mind, from New Horizon College of Engineering. What ambient temperature can the Kobo handle, both at the lower end and the higher end? He has not asked, but I'm adding lower temperature and range of temperatures.
So the cobot is designed for 0 degrees to 50 degrees centigrade, 0 to 50. So in typical Indian factories, like Bajaj is one of our largest users. So Aurangabad in Maharashtra is quite a hot, humid.
So you don't need to air condition the.
No need to air condition. Up to 50 degrees, no problem. And it's for those of you familiar, it's IP54 compliant. If you're familiar with IP5 means it's dust protected, and 4 means basically from a water standpoint, it can handle dripping water, not a water jet. So IP54 compliant from 0 to 50 degrees.
Okay. But maybe as a provocative question, for the future, you might like to do research and development up to IP67.
Yes.
Not because many people are submerged under the glass of beer.
Yes.
But I feel that that joints and the cables which are coming into the Kobo arms,
yes,
partially I think they may be IP67 protected.
Yes.
Which overall the Kobo may be IP54, but the cable joints is extremely important to have the IP60 up to 67. Right. 69 may not be, because that is a submerged in the deep sea.
Yes, yes.
There is another interesting question from a company. After adding tools to Kobo arm, is it still safe to work with people, or we need extra safety sensors or a cage? That's a very fundamental question. You can take it.
Yes. Whoever asked that question, that's a very, very intelligent question. That's a really good question, because you're absolutely right. A cobot may be safe. It's designed from ground up. It's running back here. If I touch it, it'll stop, right? All that is there. But what happens if I put a sword or a knife in the hand of the cobot? Is it safe anymore? Answer is no. It is no longer safe. Therefore, you have touched a very good point. We must always do the risk assessment of the entire process. Okay, so let's assume I'm doing a palletizing application. The cobot may be totally safe, but now I've put it on a 7th axis, which means it's going up and down. And an operator, he puts his head underneath the box, he can get crushed. He'll say, oh my God, but you told me it's safe. It's exactly the point. We have to do a risk assessment of the entire application. So depending on what you're doing, how, let's say, pointed the tools are. So quite often, there are many tips we have. For example, when I'm carrying a component, I can make the robot face inwards, right? So that it's away from an operator. I can have only the smooth portions touch the operator and not the sharp portion. So there are many tricks we have, but you're absolutely right. The entire application needs to be risk assessed for the entire application to be collaborative. So good question. You must do a risk assessment by a professional risk assessor to ensure safety of the entire.
Do you have a risk assessment questionnaire on your website?
We do. In fact, there are many companies like Rockwell Automation that have a full risk assessment team. We did a big project, for example, in PepsiCo, right? PepsiCo prefers to use their own internal risk assessment because each company has their own standards of risk assessment, right? So sometimes it's extremely high. It's much higher than OSHA standards also, right? OSHA is the safety standards of America. So you have to be compliant to that company's safety standards, and each company.
But as a manufacturer, Mr. David, I may recommend you to have from the machine point of view, from the Kobo point of view, you may like to have a checklist.
Sure.
Fair enough. There is an interesting question. You already touched about PepsiCo. One person is asking, he's not revealing his name, so I think he's working for the competitor. He's asking for food processing industry. How many applications globally Universal Robo has done in food processing industry, beverage and food?
Yeah, so like I said, we've got 46,000 installations globally.
Yes.
And while a majority are in machine tending, so about 20,000 should be in machine tending, the next biggest application is in food processing, right? So I don't know the number, it may be 20,000 or something like that, but the main applications in food processing are very, very, very significant. In fact, in India, it's the largest. It's higher than automotive. So in things like carton erection, so let's say at the end of line, the box has to be made, right? Today, it's manually done. The boxes come flat, somebody's putting the boxes together, taping it. Box erection has become a very common application with cobots, where a cobot with a vacuum gripper picks it up, and the box is made automatically by the cobot, right? Sometimes the taping also is done. The second application is case filling. This is called secondary packaging. In other words, let's say I've got a shampoo box, right? Putting the shampoo into the bottle is primary packaging. But taking that shampoo bottle, collating, let's say 12 of them, and putting them in a box, now that becomes secondary packaging. That's another very common application that we're seeing, right? Collating a bunch of, let's say, Colgate toothpaste and putting them into a box. The third thing is tertiary packing, which is taking that entire case and putting it in a pallet, right? Ready for shipment. So these are the three types of applications we mainly see. Of course, we do things like chocolate handling and in a smaller level, which is absolutely primary packaging, right? That is also happening. So whoever asked that question, that's let us know what your requirement is. We can talk.
I asked them to reveal their identity. So next time, Bangalore Chamber should be cautious and not accepting people who don't want to reveal their identity. Now, very interesting question comes from a very large group in hospitality industry. It is about butler robo. I heard about this concept of butler robo from somebody. Meaning, can you take the food from the kitchen to the table instead of a waiter doing it?
Yes.
Can a Kobo do it and then serve the food and the beer? I mean the coffee.
Sure, there's lots of people doing. Mr. Jagannath, would you like to step in there, or
yes.
Would you like to answer?
Yes,
yeah.
This can be from Mr. Jagannath. Yes.
So the AGV which we just showed can have a defined mapping of the restaurant, and there can be a triggering device on each of the table where the customer is sitting, and then you can have a pop-up there like what kind of food he wants to order. So the whole thing can be integrated, and actually the Kobo comes with a DC bus available where it can draw power from the AGV power bank itself. Okay, so end of arm effector with electric gripping kind of a thing which can handle the dishes and then move from one table to another table. It can be done. Only question comes is like, what kind of solid liquid, what is it, what kind of this thing. So again, tending from the kitchen to the, intermediate table or the point from where the server actually carries physically, that needs to be ascertained. If that is very clear, it can be done. And there is a good solution from the cobot side because it can work on a DC bank, which is very lean, very light. So your charging ability of the AGV can be once in a day. It's not very frequent, unlike the other Kobos. So there is a good feasibility possibility there. So if someone is interested, we can use the Kobo and integrate and do a good job. We can do a high-tech job. including up to the billing, everything can be automatic. Once you finish this thing, that you acknowledge it, the bill also will come to you on your mobile. To that extent, it can.
No, it looks like that the way Jagannath is narrating, he may not disclose, but it appears to be already is working on a very, very real life inquiry in the Indian industry. Best wishes to you to implement that, because the hospitality industry is now declining because of the social distancing. Maybe these kind of applications will really prop up, because when the overall economy improves. Other day I came to know that IMF has projected minus 10% GDP growth for year on year for Indian industry. But some sectors are at minus 70%. Some sectors are at plus 40%, like healthcare, for example. Agro and e-commerce is at plus 70%. None of us are going to a shop to buy anything. So I think the overall weighted average of the Indian industry is minus 10%, which is very sad. We wanted to have a plus 7% on the economy, our overall economy. Now, all this, Jagannath and Mr. David, brings to a very important question, is the question about appropriateness. That is where the unemployment and shortage of skill arises. One interesting question has come from a New Horizon College student, not mention his name. I'm sure all students will have this concern. Will this create a decline in the requirements of engineering college students to get a job, or will it have an increase in the requirements? If so, what skills and training are required, both for COBOS and for digitalization? Both of you can address this question. It's a very generic question. Although one student is asking, I'm sure all the people, both students and the industry people, will be benefited from this answer. Thank you, sir.
Okay. I can take that.
And of course, so, after
I'd like to actually show a little, because this is a great question. I come across it quite often.
Okay.
And okay, so I hope you can see this screen. For example, do you see the screen? There's a lot of women working with cobots.
Yes.
Okay, so here is women empowerment. It actually shows people getting jobs because of cobots. Okay, so I want to actually focus on one particular one, top right. Okay, this is a company called Aurolab. Aurolab is, they make lenses for the Arvind Eye Hospital in Madurai, right? Everybody's heard of the Arvind Eye Hospital, I'm sure. And this particular company, Aurolab, has 90% women, okay? And you can see the cobot is back. This girl is loading the CNC machine. This girl has got a teach pendant in her hand and she's programming it and all that stuff, right? So the question was, how about jobs? Let me take you to the, sorry.
Unshare.
Just 1 second.
In that gap, I welcome Mr. P.R. Parasuraman, Managing Director and President of Toyota Engines. He's just joined. He's the President of Bangalore Chamber of Industry and Commerce. Yeah. Sir, if you could come on the video, we would like to welcome you, sir. Meanwhile, Pradeep will continue with the answer.
Chandramouli sir, even Ravichandran has allowed.
Yes, I admitted him. Dr. Ravindran can also come on the video.
Thank you, Mr. Chandramouli. Thanks a lot.
Please come on the video, sir. It's an honor to have both of you. Yes, please explain that, Mr. David.
Okay, so in this case, as you can see, there are 90% women, okay? You can see only women here. You see the cobots at the back. Now, talking about job creation, this particular company used to make, in the beginning, only for the AEH, Arvind Eye Hospital, they used to make cataract lenses. Today, they are making lenses which are sold to 150 countries worldwide. This is 8 years later, 6 years later after their cobot journey. They had a small manpower of 10, 20 people at that time. Today they have 700 people. Okay, they used to make 150 lenses per day, which goes in your eye. Today they, with the same equipment, okay, they're making 10,000 lenses a day. Okay, so what's the moral of the story? The moral of the story is not that, hey, I put in a robot and I'm removing a human being. That's valueless. The value of putting cobots is increasing the size of the cake, not having the same cake and everybody divvying it up. Okay?
Absolutely.
So this company has showed that when your quality goes up, their quality went through the roof because instead of human beings handling it, cobots are now handling it, right? The quality has gone up so dramatically that 150 countries are importing Indian products because it's so price competitive, so quality competitive. Because of that, they have to hire 700 people, not just workers, but salespeople, export people, people in the foreign countries to do their business, right? So the answer is, it's not, don't put a robot to remove one human being. That's not the answer. If we stay at the labor arbitrage and not value arbitrage, we have to, as a country, climb up the chain of value. We have to provide more value, better quality. German cars are known throughout the world as having fantastic quality. How many Indian products do we have that are needed around the world because their quality is so good, right? So I think we as manufacturers need to aspire, instead of saying make in India, we should say make with quality in India, which basically means use technology the best you can, such that your quality is so much, your cost is down, and your business is thriving, and you're creating more jobs. So that's my answer to the question, right?
That's a brilliant example where the overall cake is growing. So it is not a win-lose option. It is a win-win option. And therefore, the Atmanirbhar Bharat, and I can see the Madurai factory there. So what can be a better example with showing an Indian case study? Excellent, Mr. Pradeep. Mr. Jagannath, I want to address the same question with respect to the digitalization. Does it displace people or it increases the overall employment in the country? Mr. Jagannath.
Yeah, very interesting question here. Pardon?
If you come on the video, it will be nice.
Yeah. So, very good question. The thing is here, even while we are talking today, there is a lot of ground to be covered on digitalization in this country, right from the legacy equipment, which are as old as 50 years, 60 years. Customers do not want to throw them away. So bringing in all this under the gamut of digitalization is a huge, big challenge. Now, the engineers or the college people who are coming out who want to just look at it, there is a plenty of things to learn and integrate, and you are integrating right from equipment like a press, and you will finally try to connect them to the existing ERP or MES. Imagine the kind of bandwidth you need to have in order to stitch each one of the fabric into the chain, so it's very complex. So you need really high quality engineers to think on this subject rather than doing a mundane job of a simple shop floor supervision or something like that. So there is a lot of demand in terms of adaptability in bringing in all this together to have it under one finger point control. So there's a huge subject here which I can talk for hours and hours, where due to paucity of time, maybe another workshop, Mr. Chandramouli, you need to start on this to talk about the skill sets. So that's where I conclude.
No, I want to tell you, on 22nd of October, I want to tell all the audience, on 22nd October, we are precisely addressing this point of what is the human development required to take up the Industry 4.0 challenges, both from running companies, what we call reskilling, upskilling, and multi-skilling aspects, and from colleges, fresh engineers coming through the colleges to these organizations, could be manufacturing industry or other industries. The various skill sets will be addressed. It's a big subject. I can see Ms. Shreya is asking this question from New Horizon again and again. It's a big topic, but one specific answer which Mr. David could give is about the Kobo industry. What are the skills required to join the Kobo industry? It's a very blunt and straightforward question from Shreya. On behalf of all the students, this is a good question.
Yeah. So I really, that's a good question from a student. I mean, if I was a student, I would want to get...
Professor. There are many professors who joined today.
Oh, okay, yes, good.
Yes.
So hopefully you saw the screens that I had on the various colleges, whether you take IITs, for example. What I like about the product is, it's great for undergraduate learning, because let's say most of you know Python programming, correct? Now you can learn on a teach pendant or I can physically move the robot, right, and teach it points. Then I can go and do a Python program and make it do the same thing, right? Then, if I'm really smart, I can go into ROS, Robot Operating System, and do low-level communication to each of the joints, right? And then if I'm a PhD student, I can do artificial intelligence research with it. So it is such a flexible tool that it's even used in schools, right? A school, my son, when he was in school, we actually did a demonstration for them as to how a cobot is programmed, because even a school kid can actually hold the arm and move it from location to location and hit replay, right? So while it can even help a small school child, it can also help a PhD student, right? So I think that is the beauty of it. What is the skill set you need? It's how much time do you want to spend on it, right? Do I want to do Python programming on it? Do I want to actually just do hand guided? For example, when we did this job at the painting location, the SME owner said, I want you, Mr. David, to train my painter to paint with this robot. Now, the painter has no education. He can't even read the screen, right? So we put the robot in his hand, in the painter's hand, and we showed him how to do the painting. And he transferred his skills to the robot that way. So what skills do you need for that? Nothing. You need painting skills, okay? So it's a tough question to answer exactly. In order to become a cobot expert.
Having said that, Mr. David, while it's a tough question, I remember I went through your website.
Yes.
There is a lot of training packages that you're offering.
Yes.
And some of them are not even chargeable. Can you just mention a little bit about that?
Thank you, sir. So if you go to the Universal Robots website, Universal Robots, there's a button there called Academy. You can click Academy if this was of interest to you. Smart kids like you all, I know within 2 hours, you can do that entire, there's about 9 modules. Okay, 4 hours, let's say. It'll take you 4 hours to do 9 modules. You will learn how to do TCP, for example, tool center point, how to set the center of gravity, how to do the programming. Plus, you'll get a certificate at the end of it, right? Just a matter of 4 hours to invest, free of cost.
It's a product-specific training.
It's a product-specific, how to program a code.
If they get trained on Universal Robo Training Academy,
will
it be useful for any other Kobo or Robo?
Yes, the concept is the same for any other robot or Kobo. The language is the same. It teaches you the coordinate system. It teaches you the, all those kind of things. So yeah. So and secondly, that's from a training standpoint. Then maybe you're the next level. You want to do simulation. Okay, I don't have a cobot arm with me, but I want to write the software and I want to see it simulated on my screen. Even that's available for free. You just go to the Universal Robots support site, download the simulation software, okay? And you can do the complete program. It's just that you don't have a robot, right? And this is how many, like if you go to Manipal, today the instructor has the robot, but all his students have the simulation software. They go back to their room, they do the simulation, come back to the classroom and put it on the robot and test it out, right? So you can do everything you have to at no cost today, just by going to the site and downloading the simulation software and attending the academy.
Are there any instructors and trainers who can guide them through on a master class that can be conducted by Bangalore Chamber of Commerce, let us say in December or January?
Certainly.
See, one is self-learning concept is one thing. Sometimes you need a hand-holding by a tutor. So I am planning to do a series of master classes, and myself and Jagannath, who is my co-chair, we are planning a series of master classes. The first one of its kind is going to be launched on 31st October. So I promised you every week there will be an engagement. So don't be in a hurry. We can't learn everything today, ladies and gentlemen. And before I invite Mr. Parasuraman and Dr. Ravindran with their video on, I would like to thank the two great speakers, Mr. David and Mr. Jagannath. They are walking libraries of Industry 4.0. They brought in a good synergy between Cobos on the one hand and automation and digitalization on the other hand. And all these are subjects which are intertwined with each other. And the three questions which are always bothering us is it appropriate for the Indian market? Is it affordable by the Indian market, especially MSMEs? And are the people ready to pick up the skills to adapt it, both from technology angle as well as a competency to maintain it? Maintenance of this equipment becomes an extremely important thing. Mr. Jagannath would like to mention the top 3 skills which he and his company are grappling when he's recruiting people in M2 Next, what are the top 3 skills or competencies? While you said you want a big workshop, I want you to quickly mention the top 3 skills, because the engineers are waiting and 125 people are still listening to us. Mr. Jagannath, the top 3 skills for any generic Industry 4.0 digital manufacturing application.
First and foremost is the adaptability, in the sense that what the market wants, or what the customer wants, or how to bring in the technology deployment. The adaptability is one thing which is very, very important. Okay, you might have scored a very good marks, and you might have got a lot of plenty of CGPAs and things like that, but what needs at this hour is the adaptability, number one. Number two is creativity. You want to find a way. Look at the applications what just David showed, right from pizza making to eye care to doing whatnot. So these are all the heights of creativity what one could really look at it. So creativity becomes number two. Number three is attitude. Okay, so with these 3 things, just go back and brush up your fundamentals as and when you look at every object to get into automation and digitalization things.
So those are the three soft skills which put together one could call as agile mindset. Correct. And BCIC is planning to do a big workshop on agile mindset through Dr. Dinakaran, who's expert on that. But I want you to mention 3 technical skills also, Mr. Jagannath, if you don't mind.
So technical skills, basically it is physics, high school physics. So if you are good at high school physics, you can do a lot of things in mechatronics, plenty of things. A lifetime is not enough. You're going to die, not fulfilling 90% of the objectives in your life. High school physics is number one, what is required. Second thing is, integrating a bit of software, bit of electronics, bit of mechanical, how to integrate this. Just try to understand.
So multidisciplinary.
Yeah, there are plenty of material available, like what just David said. Now go to my website, everything is free, but there are no takers, they don't read. So you need to have little bit of everything, and there are people ready to help. You call any one of these technical guys, they will be very eager to explain to you. So just have that high school physics. Second thing is a little bit of everything, how to integrate. Number 3 is how to bring in all of them together with the right understanding. Like you were talking of IP67 and David was talking of IP54. So how to convert IP54 to IP67. There is a jacket available which can do IP67 job. So you don't have to wait for the robot to come in with IP67 specification. So just have this understanding and find a way out. There is always plenty of things to meet your creativity. That's it. Thank you.
Great. The other day, I was doing some work for somebody and found in the next 5 to 10 years, the engineering colleges should analyze the job profile of 2 major jobs. All of you could make a note. 124 people still on the listening. 2 major jobs: digital manufacturing engineer, which is a smart manufacturing engineer. Number 2 is factory automation engineer. These 2 are interrelated, but also could be standalone basis. And today we have Mr. David and Jagannath. They are virtually representing these 2 job roles, but at a business head level. But below them, there are many team leaders with these skills. Below them, there are many technicians. A whole organizational structure is going to be developed. Is there a BFW M2 Next Academy where people can either on a chargeable basis or free basis download some training syllabus, Mr. Jagannath? Are you planning one?
We are planning one, not in place as of now, but when we are looking at the last 1 or 2 months development things, the way it is going up. So I think we will soon come on that platform. We have not yet as of now. We are just a year old. So
a leader in the machine tool industry, in the top 3 machine tool industry in the country is BFW, and its subsidiary. If you can start a digital academy, it could be on a chargeable basis. Doesn't matter. Some foundation courses can be free, but the moment you move into the high technology courses, obviously the value addition will be much more than the charge or the payment. In the last 5 minutes before we close, I request Mr. Parasuraman and Dr. Ravindran to say a few words, thanking the speakers as well as their vision for the Bangalore Chamber of Commerce on Industry 4.0. We will have a hard stop at 1 o'clock. Mr. Parasuraman and Dr. Ravindran, sir.
I will leave the final vote of thanks to the President. I am based in Bangalore and I have been part of Mr. Chandramouli's group and been involved in.
But we need a robot to lift you perpendicular. You are horizontal.
Thank you for all the automation that is in vogue. I could do it immediately. Thank you, Mr. Pradeep David, Mr. Jagannath. Very engaging session, and I was there on and off. My apologies for that. But to be engaged with 150 plus attendees and to answer these questions was remarkable. The kind of presentation that came up is something that was mind-boggling, and above all, handling Mr. Chandramouli and his vast knowledge in terms of his expectations and the questions is something that is very daunting. And as a moderator, and it's a very daunting exercise for anyone to be sitting on the other side. And all of you did an exemplary job. I must thank the Secretariat for getting the required numbers. I think we were more than 260 to 75 participants in registration form. Some of them could not possibly join today. The session was excellent. I think it's recorded and it is going to be made available in a library for years to come to maintain, manage, and then revisit the scenarios. I'm sure such kind of engaging conversations will happen again and again from BCIC. And Mr. Chandramouli is there and we are all there to support him. Thanks to Mr. Chandramouli, the speakers, the audience, and the Secretariat. And thank you for inviting me. Over to the President.
Thank you, Dr. Ravindran. I want to just tell you before President comes on, please call Mr. President, is that the next week, 22nd October, is by 3 European companies, Siemens, Schneider, and Festo, the 3 leaders of automation and digitalization. 3 European companies are talking about the human development. I don't want to use the word skilling, which looks like very, very mundane. It is a competency, knowledge, skill, attitude, all those things which our speakers spoke about will be addressed in a detailed manner in the next 22nd October. Over to President, Mr. A.R. Parasuraman, sir.
Thank you, Mr. Chandramouli. Very good afternoon to all of you.
I want to see your face. Okay, sir.
A very good afternoon to all of you, and I'm very, very happy and delighted. I was just listening to the last half an hour of this session. Sorry that I could not join due to unavoidable other meetings, but I could see the usefulness of this topic. In fact, I'm very happy to see the overwhelming response today. 126. I have promised Mr. Chandramouli 125 yesterday, so I'm very happy I hit my target. But definitely the registrations crossed 250. So our OE is 50%. Then it is a reflection for the Bangalore chambers. But looking into the topics discussed today, I think I should say whoever attended today are very, very lucky. Let me tell you from the bottom of my heart. It's a great golden opportunity. In fact, I felt very bad I missed this session. Wonderful session. Last few points that I was listening to Mr. Pradeep David, South Asia Universal Robo Head. I think amazing examples and very easy to understand concepts. In fact, I was very happy when he explained the point when to use robo. And robo is not just automation. I think ultimately everything is economy. In fact, I recollect when I installed the engine plant for Toyota, typically our biggest target was to establish a low-cost organization, global competitiveness, the key point. But I challenged and I said we should develop our own AGVs because cylinder block and cylinder heads, very heavy to transfer. And you will not believe, we developed our own AGVs with our own PE team in less than 3 months' time. And today we have more than 20, 30 AGVs running in the plant. And we could eliminate close to 40, 50 people because of this. Very simple concept. All they do is, take the Kanban signal and transfer the, machine, the block, cylinder head and crankshaft from the machining line to the assembly line. And now we have gone to the advanced level of, Wi-Fi with automatic remote signaling. and they're able to sense the Kanbans also. And similar automations, we have also put many small automations in the cylinder block line as a pusher. I can confidently say we have saved more than 50 manpower by a very small incremental investment. I think this is the power of, we call it as karakuri in Japanese. Karakuri is a small miracle. And karakuri is a usage of natural gravity and low cost power. It is like, zigzag puzzle. So you touch one place, lot of linkages will work automatically, it pushes something. I think that is the mechanical portion with a little bit of automation. And today I was very happy to see the cobot presentation. I think where humanoids and cobots, robots can work in tandem. I think today that is the order of the day. Therefore, going forward, I could see all these technologies, artificial intelligence, robotics, 3D printing, and digital transformations, and big data, and quantum analytics, and machine learning. All these things will integrate to form a new set of manufacturing. And as rightly said by the speakers today, it is not just automation. It is the value sense that makes for us. In fact, if I look at India, today when I compare it with the global economies such as Thailand or Indonesia or Philippines, these are the comparable countries for Indian market. And I'm able to see a drastic increase in the labor cost in Indian economy. See, at least 5 years back, India was definitely competitive. But really, if you ask me today, where do we stand in terms of labor competitiveness with respect to Thailand or Indonesia or Philippines or Taiwan, which are all very nearest countries competing India, I would say that definitely there is a very tight rope running. And sooner or later, India will lose its competitiveness. And that is the time, definitely the day will open up. Today, all of us are telling India labor cost is very cheap. We can always afford to have a little more labor. I think this is killing ourselves, I would say, because we are not looking into the long-term planning. Ladies and gentlemen, please take it from me. 5 years down the line, 10 years down the line, there won't be any blue-collar jobs available for us. There will be huge shortage of skills. Even today in the COVID crisis, we are able to see such kind of a trend coming in all the industries. 5 years, 10 years down the line, this is going to be a major challenge for India's global competitiveness. Manufacturing competitiveness. Today we are at 8-9%, and if you have to achieve 25% of GDP, this is going to be the game changer. And therefore, I think how to smartly automate at low cost, utilizing all these technologies. And I think this is very, very important, not only for big companies, for MSME, the small companies, low-hanging fruits are available. I think it is left to us. I'm very sorry to see that many companies are not utilizing this opportunity, because there are lots of small things can be done. In fact, when I introduced IoT in my shop floor, in fact, when I talked to the management, they were wondering what it is. But today, I can confidently say most of my machines are connected, and all the spare parts are automatically ordered, and all the predictive maintenance and predictive analytics, we are able to get it online, and we have been able to save, I would say, thousands of
Give me 5 minutes. I'm just getting off a conference. 5 minutes, I'll be there. Okay. Sorry about that.
Therefore, I don't want to take much of your time.
Okay.
But I would say today has been a golden day for all of you. As Mr.
I'm sure.
Chandramouli said, you're all very, very lucky today. You will never get this golden opportunity. And when I saw the profile of 3 speakers, I think Mr. Chandramouli is a walking library. He's one of the nations, I would say.
Moderator.
He's a pride to our nation, because I know him very well. We work together in many platforms.
Moderator.
And Mr. Jagannath is another walking encyclopedia. I think M2 Next, when I was visiting his factory, I used to wonder how BFW completely transited in a short time. I think hats off to Mr. Jagannathan. I also listened to him in several platforms together with Mr. Chandramouli. And today I had the privilege of listening to Mr. Pradeep David. I think, thank you so much, sir, for your valuable time.
Thank you,
and definitely you are an asset to the nation, because whatever work you have done today, and I could see a beautiful robot in your background, cobot. I think, I'm very happy to see that. So I would like
that's a real life one. That is not a video.
I know.
It's a real life one. You can touch and.
So I want you to make a presentation to the bigger audience in our manufacturing panel as well. And I would like a very strong appeal to come from you. And I'm sure that we can also make a similar presentation to the MSME Council, which we have created this year under the chairmanship of Mr. Indu Shekhar from Volvo. So with the limited time, I wanted to say more because it's also my passionate subject. But I'm very, very happy. And I'm very sure we can take it to the next step. And Bangalore Chamber of Industry and Commerce, we will give the fullest support, and it is a blank check for all of you. Once again, I heartily thank all the three speakers. Mr. Chandramouli is IoT 4.0. Once again, thank you, Mr. Pradeep. Thank you, Mr. Jagannathan, and thank you, Mr. Chandramouli. And thank you, audience. I think without you, it would not have been success. But I'm sure this day you will remember in your life forever. Thank you.
We still have 100 people listening. Thank you so much.
Thank you.
And I would like to thank on my behalf Mr. David, Mr. Jagannath, and all the office bearers, Mr. Parasuraman, Mr. Dr. Ravindran, and all the 150 people who entered. I had to put a restriction that after 11:30 I did not admit the other people who wanted to get in. Otherwise, it would have crossed 250. We had to maintain a time discipline. Half an hour was quite a long buffer for people to join. Anyway, it happens. That will make them next time join on time. Thank you so much.
Thank you.
Let's adjourn for lunch along with the Kobo. Thank you.
Thank you, sir. Thank you very much. Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you so much.
Thank you, Chandramouli, sir. Thank you, President, sir.
Thank you, Prithvi. Thank you, Rupa.
Thank you, Ravindran, sir.
Thank you, Secretariat. Thank you.
Thank you, sir. Thank you, Jagannath, sir.
Thank you, Mr. Chandramouli. Wonderful.
Pradeep David, sir.
Thank you.
Thanks to all. Thanks to Rupa.